Hello everyone, welcome back to BC Calculus. We're still in lesson number 34 where we're talking about partial decomposition. In the first video I showed you guys one particular method for partial decomposition, and in this video I'm going to show you what we call the Heaviside method, which is just another way of solving partial decompositions. One thing I just want to say about Heaviside method, as you guys can see right here, the only time that this works is if you have in your denominator, when you factor your denominator, you have linear non-repeating factors. So a repeating factor would be something like if I had x squared times x minus 1. This would be a repeating factor. I do want to say something about this a little bit later in time, but right now we're going to assume that once we go through our factoring, we are left with just basically lines. So y equals x minus 2, and y equals x plus 5. That would be a linear non-repeating factor. So no x minus 2 times x minus 2. So if we do that, then all you have to do is this. You can actually say, go ahead and factor it out like you normally would. And remember, like we did in the previous one, we have a over our first factor, b over our second factor. And in this particular example, we have 3 factors, so we have a c over the third factor. Instead of multiplying everything out and saying, okay, well, x equals 0, we see what's going on here because it may be hard to find the other 2 variables. We can easily say, well, what will make a go away? So if I make x equals 0, this term right here will go away. All you'd have to do, if you want to solve for a, let's make x equal to 0. Let's make x equal to 0, and you just have to look right here. You just have to look over here. Now, you want to get rid of the term that is underneath the a, which is what you see right here, and then you're going to plug in 0. You're going to plug in 0, and you're going to get 4. You're going to plug in negative 2. You're going to get negative 2. You're going to plug in, you're going to plug in 0 and get negative 2. You're going to plug in 0, you're going to get 5. And then if you start evaluating this, you can get 4 over negative 10, which is going to give you negative 2/5. So that's what you need to do to find A. And then if we want to go and find B, well, let's look what's underneath B. Well, what would make this undefined would be x equals 2. So we're going to let x equal 2. But again, ladies and gentlemen, we're just going to look over here on the left-hand side. We're going to eliminate the term that makes this undefined. And then we're going to plug in 2 everywhere. So 2 plus 4 is 6. This is 2. 2 plus 5 is 7. And then we evaluate that and we get 3 over 7. We do the exact same thing with C. We set x equal to negative 5. We evaluate that here. Again, we would be eliminating x plus 5. And then we evaluate, and that gives our values. So again, this is a really awesome way of doing the problem when we have a linear non-repeating factor. So let's actually do a problem. Let's try a couple problems here. So for this problem right here, we're going to go ahead and, I always say so this question right here is actually very interesting because you could actually use up. So this one, we're going to do it both ways, but, I always like to just throw some problems out there that's a little different. If I use this problem right here, and I make this use up, then you're going to see that if I make my denominator equal to x squared plus 2x minus 3, my numerator is going to be, so my derivative is going to be 2x plus 2. Well, my derivative, if I pull out a 2, I'm left with x plus 1 dx. So if I pull out a 1/2, then I'm going to get x plus 1 dx. And that's exactly what you guys see right here. This is our du. So I can essentially say that this is going to be 1/2 the integration of 1 over u du. And so our final answer would be 1/2 the natural log of the absolute value of u. But let's go ahead and plug in what we see here, which is going to be x squared plus 2x minus 3 plus c. And so this is how you would most likely do this problem. This is what I would suggest that you do. So in the first video, I always said, let's look at the denominator. Let's make that u for a second and make sure the derivative's not plopped right there. Because if it is, then you can just use u sub. So that's method 1. But let's go to the actual Heaviside method. So if I look at the Heaviside method, I'm going to go ahead and write the problem out again. But I'm going to go ahead and factor the denominator so we can get our factors. And another thing I want to mention that I said in the first video is that we know we can use partial decomposition because the degree in the denominator is greater than the degree in the numerator. So that's one of the ways. If these were equal to each other or this was higher, you would have to use long division if this doesn't work out. So we're going to get 3 and 1, and we're going to get a positive 3 here and a negative 1 here. So we're going to go ahead and set this equal to the integral of a over x plus 3 plus the integral of b over x minus 1 dx. And so what we can now do actually to solve the problem using the Heaviside method is, okay, well, let's make x equal to -3. And so we're going to look over here on the side and we're going to eliminate the term that's actually going to make this undefined. So we're going to plug in -3 to just simply this right here. So we're going to get -3 plus 1 over -3 minus 1, and that's going to give us a -2 over -4, which is going to give us a positive 1/2. So this lets me know that this is simply our a. That's simply our a. So again, you're going to set your denominator equal to 0. You're going to find out what that value is. You're going to eliminate that term over here, and you're going to plug -3 into what's remaining, and then you're going to evaluate. And then whatever this sum is actually going to give you your a. So I now know that this a value is going to be equal to 1/2. And yes, I could put it in the front, but right now we're just going to leave it right there for this. So let's actually go and look at b, because this actually is a pretty nice method, so you don't have to worry about cross multiplying or anything like that. So let's look at b. So if I set x minus 1 equal to 0, I get x equals 1. So this is a nicer one for us to do. We're going to go ahead and evaluate the left-hand side, but we're going to eliminate the one that's underneath the b. So we're going to plug 1 into here. We're going to get 1 plus 1 over 1 plus 3, which is going to give us 2 over 4, which is also going to give us 1/2. So the b in this actual equation is going to be equal to 1/2. And again, all we're doing, this is just a method to show us if we were to actually add these fractions together and simplify the numerator, we're going to be left with x plus 1. So that's the easiest way for me to explain that. So now that we have that, what we can do is just now do basic integration. So now the rest of this problem becomes us just integrating. So let's actually do that now and then compare our answer with what you see down here. So I'm going to go ahead and I'm going to pull out the 1/2 in this integral. So I'm going to be left with 1 over x plus 3 dx. Go ahead and pull out the 1/2 on this one as well, and you're going to see 1 over x minus 1 dx. We're going to use u sub for these problems. So u is going to be equal to x plus 3, du is going to be equal to 1 dx. This is going to be, u is going to be x minus 1, du is going to be equal to 1 dx. So we can basically say that this is going to be 1/2, the integration of 1 over u du, plus 1/2, the integration of 1 over u du. All right. So I'm going to go ahead and really quickly erase this piece because I'm going to need a little bit more room later on in life. So when we integrate this, we're going to have 1/2 the natural log of the absolute value, while our u in this case was x plus 3. And then we're going to do plus 1/2 the natural log of, again in this case, was x minus 1 plus c. And so this is the answer that you would be happy with, and we would absolutely 100% be happy with if we did partial decomposition. But let's say we do this and we compare what we have right here in orange with what I have in here in blue. And you're thinking, okay, well, how are these equal to each other? Well, the first thing I could clearly do is pull out a 1/2, right? Pull out 1/2. And so I would be left with the natural log of x plus 3 plus the natural log of x minus 1. Well, you guys remember that the natural log of a plus the natural log of b, the natural log of a plus the natural log of b is equal to the natural log of a times b. So this would be equal to the natural log of the absolute value of x plus 3 times x minus 1. So that's a property of exponents. And ladies and gentlemen, if we were to factor this back out, there'd be no surprise that we'd get this right here back. So we are now equal to each other. So two methods to solve this problem. I said I really like this problem just because it lets us see how to do it with u sub. Remember that u sub is always on the table, and then partial decomposition is also fine with this. So let's look at one more example. And this one we're going to, again, u sub's not going to work here because the derivative of just x cubed is 3x squared. That's not even up here on the top. So I'm going to go ahead and just factor things out like this. And then this one, this one we definitely would like the Heaviside method just because it's much nicer to, it's because we have 3 terms. So the Heaviside method's really awesome for 3 terms that we want to use. So let's go ahead and look at this problem. And again, I'm going to have the integration of a over x plus b over x plus 5 plus c over x minus 3 all over dx. And so let's actually solve the problem. So let's actually go through and see what we get for each one. So for a, x is equal to 0, right, because this gives you 0. And so we're going to be left with x minus 1 on the top, and then we're going to be left with x plus 5 and x minus 3 on the bottom. This is what we want to evaluate. Okay, we're going to get rid of, because normally we would have had x here if we factored the bottom part. So we plug in 0, we're going to get negative 1 on the top, we're going to get 5 on the bottom, times negative 3, and so we're going to be left with 1 over 15. And it's going to be okay that we have a really nasty number sometimes. So a is going to end up being 1 over 15. Then let's go ahead and look at b, and then I'll erase all this stuff here in a little bit of time. So for b, x is going to be equal to negative 5. Right, so we're going to set this equal to 0, we get negative 5. We're going to go ahead and plug in our equation here, like so. So we're going to have every term except for x plus 5, and we're going to get negative 5 minus 1 is negative 6. We're going to get negative 5 times negative 8, and that's going to give us negative 3 over 20 when we all simplify it down. So b is going to be equal to negative 3 over 20. And, hopefully you guys are getting the idea of what to do here, because this is, I think, one of the easier concepts that's actually in calculus. So let's really quickly look at c. Well, c we're going to say is actually equal to 3. And so we're going to have x minus 1 over x times x plus 5. So every term but x minus 3. We plug in 3, we're going to get 2 on the top. We're going to get 3, and then we're going to get 3 times 3 plus 5 is 8. And we're going to get 2 over 24, which is going to equal 1 over 12. So c is going to be equal to 1/12. And, I'm just going to tell you right now, just looking at the problems and seeing what's going on here, you guys realize that all of these, if I made this u, or this u, my derivative is always 1. So you always want to try that. You always want to make sure that you do use substitution for these. But the point I'm making here is this. I know that this integral is going to be equal to 1 over 15, the natural log of the absolute value of x. That's going to be our first part for a. I know that for b, we'll go ahead and erase that. I know for b, it's going to be negative 3 over 20, and it's going to be the natural log of the absolute value of x plus 5. So this is just a really nice time-saving problem. And again, I'm being cautious, and I did one of these in the first video, is that remember that you have to make sure that the derivative of each of these things are 1, just like they were up here. So then you can automatically just know that this is the formula for this. You can simplify this if you want to by, multiplying these two together and dividing by this, but most times that's not going to happen. That's usually going to be what you want to use as your answer. So just like I said, if I was asking you guys to do something like 2 over 2x plus 1 dx, you would want to do u sub as 2x plus 1, and then you would want to pull out a 1/2, right? You want to pull out a 1/2. So that's the only thing I'm just saying about this. And like I said, I did this in another video. So I'm rambling now, so I'm going to stop doing that. I hope this was helpful for you guys, and I will see you guys in the next video.